Hello, I am Gerard and I'm the CEO and co-founder of Eurekite. Before I start, I would like to thank SIEQ for the opportunity they gave me to present here. So, first of all, I need to explain my background so you understand why I'm invited here. I am originally from a city near Barcelona in Spain, and I went to the University of Barcelona to study chemical engineering. In my studies, it was all about processes. In other words, chemical reactors, big tubes, distillation columns, etc., etc., etc. But during my studies, I also got a good background knowledge in chemistry and material science. So when I finished my studies, I decided to move from field to field. And at that point, I went to Mesoplast Institute for Nanotechnology to do a PhD in material science. When I started my PhD, first of all, I had to learn a lot about material science and I had to learn a lot of new techniques. By the way, I got really passionate about using microscopes back then. The point is that during my PhD, I also invented flex ceramics that now you will see in a video. So as you see, this material looks like tissue paper. It is light and flexible, but it's 100% ceramic. So for instance, it doesn't burn. And now we will see again that even after burning, it retains its flexibility and lightweight. So with this material, we decided to create Eurekite to commercialize the material. We think that this material breaks all the stereotypes in material science. Just let me tell you a little bit about ceramic materials and about our material. Ceramic materials are very well known for many years. Actually, human beings use ceramics since prehistory. In Stone Age, they started using ceramic materials, which was one of the first materials that human beings started using. Ceramic materials are very well known and their properties especially are very well known. They are resistant to heat, but they are also brittle and they are also heavy. So now, we are making a material that is light and flexible and still retains the main physical-chemical properties of ceramic. That's why we call this material a technology platform, because it enables many innovations in different fields. In our case, we are working in the field of flexible electronics. Let me tell you why. Normally, electronics are placed on those iconic green cards that we find in every computer. But industry evolved in two different directions. First of all, flexibility, and secondly, high performance. With regards to flexibility, they use polymer substrates and they place conductive patterns on top. Since the polymer is flexible, the overall device is also flexible. But as you know, polymers degrade at high temperature and they don't have the best dielectric properties. So we want to have high performance electronics. What is used nowadays is ceramic substrates that can resist these high temperatures and have very good dielectric properties. But still, ceramic is a ceramic, so it's heavy and it's rigid and brittle. What we are now doing is to combine the benefits of a polymer and a ceramic, so we can have a light, thin, flexible device which at the same time can resist high temperatures and have better dielectric properties. With this, I would like to generalize a little bit in material science and chemicals. Materials and chemicals are at the bottom of the value chain and they enable new innovations in the layers above. But what you should understand is that everything starts from materials. To bring new innovations, we need new materials. I want to give two examples. First of all, if there were no semiconductors, the electronics industry that we know nowadays would be completely different. Semiconductors allowed humans to build microchips, and from microchips then we started building computers, laptops, cell phones, everything that we know nowadays. Another innovation is in the field of biomaterials. For instance, in dentistry, they invented biomaterials so we can have dental implants. Can you imagine how dentistry would be if there were no biomaterials? So now, relating back to flex ceramics, With flexceramics, we show that we can change the basic properties of materials. And this allows us to enter into a new era that I would call a design-based materials. In other words, first we have to choose what properties we want, and then we change the materials to fulfill all the specifications. This is going to be the key to bring many new innovations. And now I want to drop two challenges. First of all, scarcity of materials. One of them is rare earth elements. We use rare earth elements in all electronics, but those materials are scarce and they come from conflict zones. Second, plastics. We are inventing alternatives to plastic fuels to provide energy, but we also need to provide plastics. So, these two are very good challenges for chemical engineers, so they can invent new materials that bring innovations for the future to have a better and more sustainable world. And to relate to chemical engineers, I just want to mention my own experience. As student of chemical engineering, I learned a bunch of techniques that became very useful for me nowadays. First of all, I understand chemical processes and mass transport, heat transport, etc., etc. I also use many techniques that are still valuable nowadays, such as microscopy, crystallography, or even the mechanical testing. But I think that the most important thing that I learned during my studies was to get a toolkit that enables me to solve problems. So, as conclusion, material science is in every possible field. So you guys have the opportunity to bring innovations by using new materials in many different possible fields. Thank you very much.